Okay, this is section 9.4, performing rotations. Okay, and rotations you already kind of learned about in Geometry A, but now we're going to talk about them again a little bit, and then also learn how to use matrices to perform rotations. Okay, so the first part, once again, is a little bit of review, and then the rest should be new stuff. So the first thing you should do is copy down these definitions. The first one is the center of rotation, and that is the fixed point about which a figure is rotated. This is the center of rotation. The angle of rotation is the angle formed by the rays drawn from the center of rotation to the figure and image. And I want to give you a picture of that in 1 second, but take a second or two to copy those down, and then you may have to pause the video, and then we'll give you the diagram here. Okay, so let's say that I had a triangle here, PRQ, or QRP, and I want to rotate it. And I want to rotate it 40 degrees. I'm going to rotate it 40 degrees about point P. Excuse me. Let's use point K. Point K. Okay, 40 degrees about point K. What that means is, and oops, I lost my triangle here. Sorry. This is R, P, Q. Okay, and so what that means is that I can kind of draw a line here from K to Q, kind of extending to R, and I'm going to rotate it 40 degrees. So this is 40 degrees, such that I end up with a triangle that looks very similar. I'm going 40 degrees about point K. Okay, well that means that I'm going to have a new triangle, and it's going to be called R prime, and then P prime, and then Q prime. That's my new triangle. A couple things here. This K is the center of rotation. Point K is the center of rotation. Okay, and 40 is the angle of rotation. Okay, it's the angle of rotation. So that are the two pieces that we kind of just defined up here, angle of rotation and center of rotation. Angle is 40, and the center is K in this example. Okay, so I want to move on to the coordinate rules for rotations about the origin. Alright, so this part, I'm going to give you a diagram. Basically the rules right here, 1 through 3, those are basically the rules that you want to use. So for instance, if I want to rotate something 90 degrees, I'm going to flip the coordinates and make it the B or the Y coordinate negative, and so on and so forth, kind of down the list here. But I do want to give you a picture of what's going on, so I'm going to pause kind of the recording, put the picture on here, and then you'll probably want to pause the video and check it out. Alright, so let's say that I start here at AB. Okay, so that's kind of this row over to the left. I start at AB. Alright, now I want to rotate it 90 degrees counterclockwise about the origin. That's how we'll always rotate things. Well, that means that I'm going to take AB, this point out here, I'm going to rotate it 90 degrees. And then connect the dot there. Okay. Now that's where this rotation comes in. Negative BA is exactly a 90 degree rotation. And we can keep going kind of around the thing. You know, if we kind of keep, this is another 90, so that's 180. This is another 90, so that's 270. Then of course 360 puts you back in the same place. So this one would be 270. Sorry, 270 degrees. If we started at AB and went all the way around. And that's all these coordinate rules do. It's just kind of move the point around the graph. Alright, in this video I want to keep it fairly short because I want to do some of these examples in class with you on the board. So what I'm going to do is give you kind of the theorem junk, and then we'll do examples in class together. This is not, like I said, kind of a hugely different thing. It's very similar to reflections, so we shouldn't have any, if you're okay with reflections, going to rotation should not be any kind of major jump. So let me give you the matrices. These are the rotation matrices for each rotation. So rotation matrices. Okay, for a 90-degree rotation, our matrix is 0, -1, 1, 0. For 180 degrees, the rotation matrix is -1, 0, 0, -1. For 270 degrees, the rotation matrix is 0, 1, -1, 0. And for 360 degrees, we have what's called the identity matrix, and that's the matrix that actually doesn't move the point at all, but in doing that also moves it 360 degrees, right? Because if I move the point around the thing 360 degrees, then it goes back to the same place where it started, okay? The process for this, or kind of your steps for actually doing the rotation, you should take the rotation matrix, times that by the polygon matrix, and my cat is helping. Matrix, Sarah, go on. And that's going to leave me with the image matrix, which is the final matrix we're looking for. Okay. The image matrix. It's kind of sloppy. The image matrix is the last thing written there. Okay? And that's it for the theorems and stuff that you're going to use. And like I said already, very similar to reflections. We'll do a couple of these examples in your notes in class so we can do some matrix multiplication together again. And then that way you've got these theorems to kind of handle. If you'd like to go through and try some of the ones on the notes, I think that'd be a great idea to kind of get ready for the homework. But it's not required, like I said, we'll go over it in class. I'll try to keep this video a little bit shorter. The other ones are kind of long, I apologize. Anyway, here you go. This is 9.4, and you're ready for the 9.4 homework.